So in our chemistry review, you now know how to, and this is a review from last year, right? You should have known this already. A chemical formula like H2O tells you what atoms is in one molecule and how many of each of those atoms. H2O has 2 hydrogens, 1 oxygen, H2O, right? CO2, carbon dioxide, 1 carbon, 2 oxygens. That's in one molecule. But you can have more than one molecule going into a chemical reaction, right? And more than one molecule coming out. And so we need to kind of understand the math of this. None of this math is complicated, but I want you to understand how it works because it fits so many different things together. Okay, so the chemistry review here, there's a rule about this. If you have a chemical reaction, anything that goes in has to come out. Matter doesn't just magically appear out of nowhere. It has to come from somewhere. If I have this pen, for example, and I probably shouldn't use one that's the same color as my green screen. Okay, let's say you have a pencil. You know, if I picked up this pencil, do you think I just magically made it appear out of nowhere? Look, magic. Oh, it came from nothing. No, I had it in my hand already. There's really no such thing in this universe of stuff appearing out of nowhere. It has to come from somewhere, right? And that's one of the laws of science, one of the laws of physics, laws of nature that has been discovered. It's basically it's called the law of conservation of mass. I want you to write this down on your paper. Law of conservation of mass says matter is never created or destroyed, it only changes form. Please write this down. This is one of the most important things that science has discovered, that matter doesn't just magically appear out of nowhere or disappear. So the picture there with the guy with the rabbit in the hat, if somebody's pulling a rabbit out of the hat, that's a trick. It's a trick. He had it already up his sleeve or somewhere, you know? He didn't just make it magically appear out of nothing. So, write it down. Conservation of mass. Matter is never created or destroyed. It only changes form. If you were in my class last year, you might even recognize this. There's a song. A song, yes. Now, I'm not going to make you record yourself singing this song, but I want you to do it. If I hadn't have done this last year with my classes, I would probably do it where you have to. But you remember it if you were in my class? Matter is never created or destroyed. It only changes form. It only changes form. Matter is never created or destroyed. It only changes form. It only changes form. There's actually more to the song. The law of conservation says it's always very clear. In chemical reactions, no atoms disappear. Matter's never created or destroyed. It only changes form. It only changes form. Hey! Okay, so I'm going to have you sing just the first part. 1, 2, 3, 4. Matter. Okay, good enough. I'm not going to make you record yourself singing it, but it's a good way to learn it. Matter's never created or destroyed. It only changes form. Now, what this means is in a chemical reaction, anything that goes into the reaction had to come out of the reaction. For photosynthesis, what that means is any atoms that end up getting produced by photosynthesis, like the glucose molecule, had to come from somewhere. It came from the air and the water is actually where it came from, carbon dioxide and H2O. We'll get to that later on, just so you know where we're heading with this. Okay, so what it kind of means is stuff doesn't just vanish from the universe or appear out of nowhere. Okay, it has to come from somewhere. In a closed system, mass is conserved. You know, if you have put something in a jar, if the jar doesn't get open, the stuff stays in there. Even if you heat it up or cool it down, it's still going to weigh the same because stuff doesn't just appear out of nowhere. Okay? So here's the deal. With chemical reactions, atoms rearrange themselves into new molecules and compounds. So write this down. A new substance are produced, but no atoms are gained or lost in the process. Okay, write that down. Okay, atoms might be, substances might be produced, but no atoms are gained or lost in the process. In short, what it means is anything that goes in, they're called reactants. They must come out. Those are the products. Oops, sorry about the image there. Oh no, it's right on my head. Ah. Okay. All right. So let's practice this a little bit. I'm going to show you a chemical reaction. So before we can get a photosynthesis, I want you to understand the process here. All right. So here's one, combustion of methane. If you're going to burn methane, is the simplest hydrocarbon. And it's got one carbon and 4 hydrogens. This is what a methane molecule looks like. Okay. But if you're doing it, what it does is combustion combines with oxygen and then rearranges it and makes something new. Okay, combustion of methane. Here is the formula, okay, for the chemical reaction. CH4 is methane, 1 methane plus 2 oxygens. That's the symbol for a chemical reaction. And then what it ends up doing, it breaks them apart into pieces, and then they get reassembled as CO2 plus H2O. Actually, now here's the thing. How many carbons do you have going into this reaction? The answer is 1. Right? How many come out? 1. How many hydrogens go into this reaction? The answer is 4. How many come out? 4, because you have 2 H2Os. You have 2 H2O molecules. That means you got 4 hydrogens. Okay? How many oxygens go into it? 2 H2O. So how many oxygen atoms is that? That's right. It's 4 oxygen atoms, because you got 2 atoms in each molecule. When you got 2 atoms joined together, that's O2. That's the kind of oxygen we have in the air when they're combined with each other. And if you have 2 of those, you have 4 total oxygens, because 2 times 2 equals 4. How many oxygens come out? Well, here's 2 oxygens coming out, and here's 2 times H2O, so here's 2 more, because you got 1 oxygen atom in every molecule of water. You have 2 molecules of water, that's 2. So it's 2 plus 2 equals 4. Here it's 2 times 2 equals 4. Everything that goes in has to come out. Okay, I want you to answer the questions related to this coming up right now. Okay?